Okay, so here we go. This is a specific heat capacity problem, and we're going to say that this is the type where we solve for Q. And it says a hot water bottle contains 750 grams of water at 65 degrees Celsius. If the water cools to body temperature 37 degrees Celsius, how much energy could be transferred to your sore muscles? Okay, so step one is to identify our unknown and see what we know. Okay, find out what's given and what we don't know. Okay, this is the equation we will be using. Q equals M delta T Cp. Okay, so let me start reading and see if I can figure out stuff. A hot water bottle contains 750 grams of water. That's a mass. Okay, so I'm going to write that here, 750 grams H2O. Okay, and I keep reading. At 65 degrees Celsius. Okay, I know I'm going to need the temperature, but and I need both temperatures because here's what I need you to remember. Delta T means the change in temperature. And in science, whenever we talk about change, it's always the final temperature minus the initial temperature. So I'm going to put here temperature final minus temperature initial. Okay, here's the deal. If you mess this up, your problem will be okay, except at the end, the sign will be wrong. It'll be the opposite sign. Will you lose partial points? Of course, but did you get the main idea? Yes, and you'll get still a good score. Okay, people have trouble final minus initial understanding which is which. So let me see if I can figure this out. There's a water bottle that has water at 65 degrees Celsius. If the water cools, when it says if the water cools, that means it's going to happen. That's what's going to happen. Okay, so that's what happens last. If the water were to cool to body temperature 37 degrees, so to me that tells me that's last. Okay, so I would write that as 37 degrees Celsius minus 65 degrees Celsius. Okay, and I put that in the calculator, and I'm going to get negative 28 degrees Celsius. Okay, so now I have that information. How much energy could be transferred to sore muscles? Okay, they want to know how much energy. Q is the energy value, so Q is our unknown. Okay, we know Q is our unknown, so I'm already going to designate this up here. The yellow usually I try to do as our unknown, or just, highlight that it's the unknown. Okay, so I'm solving for Q. And as some of you got stuck, okay, it was because of the Cp of water. We forgot that that's something that's given to us. So I'm going to write that down. That's something you'll know, but you'll get used to it now that you've done it the first time. 4.184 joules over grams degrees Celsius. So it's kind of a weird unit. My setup. And the reason that the Cp is this, it's not because it's told in the problem, because it's H2O. Okay, it's water. Every specific thing has its own specific heat capacity. Like I said, a lot of these problems we do in water, so this is really the only Cp you have to worry about. Other times you solve for Cp when the item is unknown, but for the most part, they're going to look like this. Okay, so that's what we're supposed to do. Now, step two, when we get to step two, as I told you guys on yesterday's notes, step two, rearrange the equation if needed to solve for the unknown. I don't have to rearrange the equation. It's already done. So here's the setup. Q equals M delta T Cp. Okay? That's the equation that I'm going to use to solve this problem. And here's my final step three. Okay? Plug and chug. We have to remember sig figs, and the units have to be the proper units. Okay? What are the proper units? In this set, for this type of math, or for this type of problem, energy is going to be in joules, mass is in grams, degrees Celsius for temperature. Okay, and to be honest, here's a secret. If you look at the units that are on the Cp, those are the units that everything has to be in. So if something is in kilojoules, you have to change it. If something is in like milligrams, you have to change it to grams. If it's in Fahrenheit, you change it to degrees Celsius. But those are the desired units. Okay, so now step three is simply going to be the plug and chug of this problem. Okay, so equals the mass, it's up here, 750 grams, 750 grams, times the temperature change, that's right there, negative 28 degrees Celsius. Again, if you did this part wrong, you're going to get 28, but you would have got plus 28, and it just affects your final answer. And then the CP of water, and this is where the units are funny. You got to make sure, 4.184 joules is on the top, and on the bottom goes the grams degrees Celsius. Okay? And what I notice is this grams is going to cancel this grams. Okay? And this degrees Celsius cancels that degrees Celsius. And you notice the leftover unit is joules, which they're asking for energy, so it sounds like I'm on the right spot. Okay? And now I do the final touches, which is the calculator work. So here's my handy dandy calculator, and I just punch in everything. Okay, let me figure out, I can do chemistry, but I can't turn on the calculator. Okay, there we are. 750 times negative 28. Where's the negative 28 times 4.184, 4.184, and I hit equals, and I get that number equals negative 87,864, and the unit that's left is joules. Okay? Guess what? We still have to worry about sig figs. Okay, here's the first thing. Don't worry about the CP. Don't use the CP. Okay, just use the other data that's given. So you guys should start to learn that constants or anything like that, they don't count towards significance. 2 significant figures, 2 significant figures. So that means that for this one, I'm going to cut off at 2 sig figs, and I get negative 88,000 joules. Remember, this 8 tells that 7 to round up. The placeholders, because negative 88 is different than negative 88,000. Okay, that's my final answer. And so what does this all mean? Because there is a lot of information here. You may not understand completely what it means. Okay, so let's spell this out, and then we'll be done for the day. Okay, the negative sign, what does that mean? Means it means heat moves away. Okay, it's a negative sign, so it's moving away. Oh, look how that matched. That random little squiggly was there, and then it's almost like the tail of the Y. The negative means that the heat moves away. How, as far as that sign, here's one thing. Okay, we talked about this yesterday. I said it doesn't make sense until we do one problem like it. As far as the sign, okay, sign, so since solving for Q, okay, calculator determines sign. Okay, and that was part of your notes yesterday. We did talk about this. Okay, that when we got to this point right here, sometimes when we solve for Q, which this is that example, the calculator determines the sign. You just punch it in the calculator and you get the answer. The second problem we'll do next time, we're going to have Q given. So you'll see how that's a little different. Okay, but for today, hopefully that made sense to you guys. Okay. Are there any questions about that one? And then we'll have to stop and leave class.